The given question is a medium difficulty problem solving GRE question. So on the topic geometry, you need to know one key concept to solve this question. Once you have a handle on that concept, the question is actually a very simple question. We are actually rotating a sector of a circle and making it into a cone. What happens is what we need to figure out. A sector of a circle of radius 5 centimeters is recast into a right circular cone of height 4 centimeters. Sector of a circle, it's basically a part of the circle. The radius is equal to 5 centimeters. When we rotate it and make it into a right circular cone, the radius of the sector will end up becoming the slant height of the cone. This is the key concept that you need to know. If you know this concept, then the question is actually done. So the slant height of the cone is equal to 5 centimeters. The height of the cone is mentioned in the question to be equal to 4 centimeters. The slant height, the height of the cone, and the radius will form a right angle triangle. Now we know the measures of two of these sides. The slant height is actually the hypotenuse. One of the perpendicular sides is the height. The other perpendicular side is the radius. So step 1, let's compute the radius of this right circular cone. So I'm going to compute the radius. Apply Pythagoras theorem. Pythagoras theorem is square root of the hypotenuse square minus one of the perpendicular sides should give us the value of the other perpendicular side. R is one of the perpendicular sides. Hypotenuse in this case is the slant height, which is equal to 5. So 5 square minus the measure of one of the other perpendicular sides, which is the height here, which is equal to 4 square. 5 square is a 25, 4 square is a 16, 5 square minus 4 square is 25 minus 16, which is equal to square root of 9. Radius is square root of 9. Radius is equal to 3 centimeters. So you computed the radius. This is step 1 done. Step 2 is to plug in the value of the radius and height into the formula to compute the volume of the cone. Quickly summarize this bit before we go into computing the volume of the cone. The base radius, which is this, slant height, and the height of the cone will form a right angle triangle, right angled here. Slant height is the hypotenuse and these two are the perpendicular sides. Applying Pythagoras theorem, computing the radius of the cone to be equal to 3 centimeters. Step 2, let's find out the volume of the cone. Volume of the cone is equal to 1 by 3 pi r squared h, which is 1 by 3. If you took a look at the answer options, all of the answer options were given to us in terms of pi. So let's keep pi in terms of pi itself. We're not going to write it as 22 by 7. If the answer had been in numbers without a pi in it, then it would have required a conversion. 1 by 3 pi into the radius, which is 3 square, into the height, which is equal to 4. 1 by 3 times pi times 3 square times 4. The 3 in the denominator will get cancelled with one of the 3's in the numerator. So the answer is going to be 3 times 4 times pi, which is equal to 12 pi centimeter cube. So volume of the cone is 12 pi centimeter cube. Quickly summarize it in a printed form. Plugging in the value of radius and height, we get the volume to be this. Answer option A is the correct answer. Quickly recap the key takeaway from this question. When a sector of a circle is recast into a right circular cone, the measure of the slant height of the resulting cone is the radius of the sector, right? This is the important property that you needed to know to solve this question. Before you leave, I want you to do two things. One, sign up as a trial user for Visaco's online GRE course at online.visaco.com. Takes all of 3 minutes and 2 steps to get started. And lastly, subscribe to this channel, youtube.com/VisacoGRE. We keep adding newer questions, give you tips, tricks on how to crack the GRE.